you. Thank you. Can you stay here just for the discussion? And even thank you because you introduced the following speech by Loreto Valenzuela. Hello, CSP, and I think Loreto is a research in the research team of CIEMAT, the Plataforma Solar de Almería. They are a research center focalized on CSP, I think, and she's responsible for the group working on online focused collectors. And I think also your perspective will be interesting because you will introduce us on small scale application of CSP. When we think to CSP in general, one thinks of big power plants. So thank you, and 10 minutes.
Okay, thank you very much, Mr. Temore. As you mentioned, in my presentation, in my presentation, I will review the. For those of you not familiarized with the CSP technologies, I will review the existing CSP technologies now available in the market, and also I will present some commercial projects. Most of them are large commercial power plants, but there exists a small, medium-sized commercial system just now available in the world. And finally, as the presentation is quite short, I will remark some challenges from the technical point of view, not from the legislative point of view, for the development of CSP for small and medium-sized installations. For those of you that probably don't know very well what is a concentrated solar thermal power plant. A CSP system is a system where the direct solar radiation is concentrated by an optical system and then converted into thermal energy. So a CSP system is producing heat at the first stage, and then is coupled to a thermodynamic cycle to produce electricity, but the thermal energy can be used also for an industrial process heat or for a solar heating or cooling application. So CSP can be used to produce heat. There are different technologies available in the market. The technologies can be divided into point focusing systems and line focusing system. In point focusing system, we have the central receiver tower systems. We have also parabolic dishes with Stirling engines, and in the field of live focus collector, we have parabolic trough collector and linear Fresnel reflectors. Starting with the technology of point focusing system, this slide summarizes the characteristic of both technologies available, the solar tower system and the parabolic dishes. I'm not going into details. You have here the details, but what is important here to remark is just now, the typical capacity of the central receiver system is between 10 and 200 megawatts, but there are emerging concepts of central receiver system for a small size, and we will see later. One important thing also is the possibility of thermal storage for solar tower system. And even there are some examples of commercial projects producing electricity 24 hours per day with a storage system. We will see now. For parabolic dishes, the option is to couple the optical system and the receiver with a Stirling engine. Here the capacities are lower, between 3 and 25 kilowatts, which is a good option for distributed generation. The problem here is there's no still a thermal storage option available in the market. Examples of large commercial systems, we have many power plants now around the world. In Spain, we have 3 power plants, 2 of them operated by the company Abengoa. Both are producing superheated steam and are coupled to a steam ranking cycle. This power plant has no storage, but there's a power plant in Spain, the power plant Gema Solar, using molten salt in the receiver. It's also coupled to a steam cycle, and this power plant has thermal storage and can produce electricity 24 hours per day. And now there's new projects, for instance, in USA, there's a large commercial project. This one, the Ivampa power plant promoted by BrightSource, is a large power plant using a steam receiver coupled also to a steam ranking cycle. Regarding commercial examples of power plant with parabolic dishes, there have been some tries to put into operation, for instance, a power plant in USA. From the company Tessera installed a power plant of 1.5 megawatt, which is no so large power plant with dishes using 25 kilowatts Stirling engines, but they have problems in the startup and at the beginning of the project, and the plan is decommissioned. And also there was a try to put in operation a power plant in Spain, also using small Stirling engines, but the plant is not operated at this moment. The difficulties for develop commercial project with Stirling engines is just now probably the higher cost compared to PV and concentrated PV. There's no storage option, so it's a technology similar to PV, and the cost of PV and concentrated PV is lower. And also there are few suppliers of Stirling engines in the market, and the reliability and durability of Stirling engines should be improved. So this is the problem now with this CSP technology. Regarding line focusing collectors, we have the option of using linear Fresnel collectors or parabolic troughs. Here, going to the important things, the capacity, the typical capacity of power plants now available in the market are for linear Fresnel, we have an example from 1 megawatt it's possible to go up to 100 megawatts, and the same for parabolic troughs. You can go from 1 megawatt to 300 megawatts of power plants. For parabolic troughs, thermal storage is available when you are using thermal oil in the solar field. So there are many examples of power plants using thermal storage. For linear Fresnel, if you are using water steam in the solar field, there's not a proven option to storage the thermal energy. So here there's still research and development to be done. There's a lot of commercial examples of power plants with parabolic troughs. The first experience was in the USA at the beginning of the 80s with the SEX plants. In 2008, started the first power plant in Spain, the first one of around 40 power plants just now running only in Spain with parabolic trough technology. These power plants use thermal oil in the solar field. Most of them are also using storage. Okay. Also, there are examples of linear Fresnel power plants in Spain and around the world. So for large systems, you see there's commercial systems available in Europe, in United States, but around the world. What are the challenges for the development of CSP for small and medium size? We know at CMAT and many research institutions, we know there's a large potential for commercial application of CSP, also for small and medium size, because the technology has been proven for large systems. There's no many difference for a small system. The potential is clear, because some of you have mentioned the replacement of conventional fossil fuels by renewable energy to do energy efficiency use, environmental restriction. So technical uses for the development of the CSP for a small system are the design of modular designs. For instance, some emerging concept for central receiver. Here you have we are trying to go to modularity. There are some examples of companies developing a small tower system. For instance, the company Aura Solar, eSolar, they are developing concept of a small system of 100 kilowatt coupled to a gas turbine, for instance, and producing also waste heat. So you have this option here, and also it's the same for parabolic trap or linear Fresnel. The concepts are proven. So what is necessary to do to promote the development of CSP for small and medium size, from our point of view, is to establish a legal framework properly planned for the short, medium, and long term of development of CSP technology, to disseminate the CSP technology through course, through master, to increase the number of professionals with adequate training, to establish fluid mechanisms and stable procedures to ensure effective communication between different sectors, the research center, the companies, the governments, to continue maintaining funding programs, to promote especially demonstration projects, to provide the industry with specific regulations regarding the standards. That's all. For more information of commercial projects, here are some websites. Thank you.
Thank you. Thank you very much.